Okay, let's get started. The questions about the procedures for your homework 12A, and let me use this one to show you. Okay, here's the data set of the same things, and let me just first have the live regression done. Okay, this is a regression you're supposed to do, right? And finance, age, race, we use all of them, right?
We also had education.
Huh?
We also had EDU, so education.
Yeah, and EDU, okay. We'll have education, and all that done, right? That's all. Well, I'll do it in the same sequence. So EDU is in after what? Is it at the very end? Fin, age, huh?
It's after prior, and it's EDU, C.
Okay. So this is correct. Okay, so when you run this, is that running? Oh. Why is it not running? I need a what?
You need a C after the EDU.
I need a C?
Yeah, ED.
I don't have a C.
Don't.
Is it finance, age, race, birth, race, marriage, PRO, PRIO?
Now let me try a different one. I'd go to download. Let's use this one. Does that one come with the everything? No, that one doesn't come with everything. I don't want to copy paste and type the wrong things. I guess I have to use this one. Yeah, let me try this one. Go back to what I have. I don't want to spend time copy paste the wrong things. Do you have education in the stuff I asked you to do?
Yes.
Education equal to 4. Okay, so then we need education. Okay. So okay. I have that's why.
How did mine run? I have a C at the end.
Huh? That's okay. Yay, it's running. Okay, here's the things I have, right? And here are the parameters. And of course, technically speaking, I already told you guys before, we should use only the one significant. But let's just say we don't care in this case. And when I said Excel, it really is not Excel, it's this. here's the file, right? So which one is my beta 0? This one is my beta 0, right? So here I have basically, let me insert one here. I can call this is my beta 0, and try to be okay, here's my beta 0. So if I do this, I'll have this is my beta 1, beta 2, beta 3, beta 4. So this is the regression parameter I have, right? Agree? 5, 6, 7, and 8. So I have a parameter. Next things I need is, I need to say that, okay, so my beta in regression, I need to time x, right? Beta 0 plus beta 1 times x1, x2, x3. So I need x1, x2, x3. Where is my x? Here's my xi, right? So now x1, finance, yes or no? What in the homework I gave you is beta 12A finance, yes or no finance, or with finance? In 12A? With finance, right? Yeah?
What do you mean?
I said the subject I'm interested in the homework, with or without finance?
With
Okay, yes, is 1. Age? 35. Race? Yes, 1, 0, 0. Work experience? Work experience? Give me the number.
It was
1. Marriage status?
1.
Parole?
1.
Prior?
5.
5. Education? 4, right? So now I basically need to do what? Every parameter need to, so the equation will be beta 0 times beta 1 plus beta 2. So my beta 0 is this guy, right? I need this number. And then what else I need? I need every parameter here times every value here. That will give me beta 1 times x1, beta 2 times x2, beta 3 times x3. Agree? Agree? So I can write it down here is that I need to have a summation beta I need to have a bunch of summation beta times x. And let me just times x. And so I need a bunch of summation beta I times xi. And what would I use as for that? I need a bunch of summation beta I times xi, and of course at the beginning I need to have a x0. So it's this times this, this times this. So all I need to do is just have a sum product of everything times everything, right? That will be all the variable I have in order to generate that specific, the lambda value for that curve, right? My hazard function, my lambda, is related to that regression, right? Or, remember? Here. Let me go back to chapter 3. Yeah. Chapter 4, I guess. Right? You have now you have all this, so you can turn this into your live regression parameter, and then you can plot it. Agree? Did you guys play with the Excel I gave you last time? Yeah, this is exactly the same thing, just I have different beta. Follow me? Don't just copy paste the answer. Yeah. Here. To do your log t, you need this part. Agree? You need a beta 0. Do we have a beta 0? We have a beta 0, but we also need all this. Okay? Make sense now? Yeah, because the Excel example I gave you just different image profile, but you're still using the same type of variable, right? So if you go through that example, now you just see that, okay, I have a new set of data. You know, maybe this is from, I don't know, Texas, New Mexico, from somewhere else, and they have different beta. And then you have to figure out the individual profile and to do everything. Follow me now? Okay. That's not too hard, right? Yeah.
A follow-up question would be like this, when we're moving on to like the next step.
Uh-huh.
And we're having to
Once you have all those variables done, look at the Excel. What I did is when I create a lambda function, and a lambda function is based on all this stuff. So now my survival time, the survival function, I have my lambda and everything, so then I can plot it.
Are we using, okay, so for like question 5, are we supposed to use like the Excel and do the plot of like the S, the F?
Yeah.
Do we do that in Excel or do we do that in SAS?
Actually, you can do it both, but I prefer, since I show you guys how to do it in Excel, you probably, it's easier just plug in and use the Excel. Yeah. Now, I'm not going to get into the difference between the two plots, but the reason I usually use Excel is that in the real world situation, I can get a SAS done in my office, but once I'm in the field, a lot of time the customer may not have the Excel, it may not have the SAS, but as long as I have the beta file, I can give them the answer, right? Yeah, Excel is everywhere. Okay, let me go back to my other stuff now. Okay. The other stuff I'm going to talk about is the following. PHREG, I already showed it to you that it's really the exercise will care less. Okay? A lot of time, the PHREG and live regression is that we only care about okay, which one is good to improve something or decrease something. So I can change the parameter and say, what if I provide 3 more years of education, or I did something extra for people? So PHREG really is the one that I only care about those positive and negative. And last time I did it, without showing you, is look at this too, okay? Live regression and PHREG looks almost the same here, right? The two up here. And you can add education in, it doesn't matter, okay? But here is the things I wanted to show you. Here. Here I have a set of live regressions parameter using WIBO. And here I have a set of parameter PHREG using live regressions. So if I copy paste, okay, here is the live regression of all the parameter. And then here is the PHREG of all the parameter. Okay? And watch, okay? It's only happen in WIBO if you let every variable of the live regression divided by, multiplied by the scale, not divided by the scale. Multiplied by the scale. Okay? Oh, I need to lock the value. Oh well, I'll do it. There's a bit differences because of the resolutions here. But if I have every value locked by the WIBO shape, okay, I get what did I do wrong? Oh, no, this one. Okay. If I put a negative sign in the front, I can use live regression to estimate the PHREG. Or I can do it the other way around, is if I use a live regression parameter, PHREG parameter divided by the shape parameter, and put a negative sign on. Oh, again, I have to lock it. Okay. Huh? What happened? Oh, the last two is not the parameter. You guys see the this value and this value are very close. See that? So PHREG and live regressions in WIBO is a very good way to cross-check your data set or your equation and everything. And of course, once you check, that's why I said a lot of time, whatever I do, I start doing WIBO, because exponential is a special case of WIBO with simple parameter. And at the same time, so if I see the scale parameter is very close to 1, that's something I like to know. And the other thing that's very good is that if I check everything's correct, I know that this data set is good to go. Then I can try the distribution equal to log normal, try different type of distribution. You guys follow me? So mentally do this. Live test, do the plot, look at the plot, the LS, the hazard function, does it look flat, and say, oh, this look like a whiteboard, look like what? And the second step, do this first. And if they look the same, you say, hey, at least I have a baseline to go. And then you can go something else. Follow me? Next, okay? Now I'm going to get back to the step I'm trying to get into last time. PHREG got two benefits. Can do tight data and can do time series data. And last lecture, I showed you guys time series could be velocity, acceleration, snap, jerk, whatever you want to do. Okay? And here, let me go back and show you a couple of things I would like to do today. First, the time dependency part I want to do is this, okay? You can ask the employment data, okay, and say that, okay, if, if the employee works, how many weeks they work, so the employed, how long they've been employed, how, did they, the week they got arrested, how long they've been working before that, accumulated, okay? So you can answer a lot of questions, almost like, oh, is the motor running hot? Is the motor running, no running before the arrest? You guys follow me? And so you can, here on page 144, I highlight several different ways to do this. And that is the regression, the SAS code, I show it to you on 144, okay? And 155, I'm sorry. The SAS 155 got all kinds of way to accumulate the time series. And here are the time series one by one. How long it's been employed, okay? And does it been employed 2 weeks or, the week before, 2 weeks before it's been hired. And if you guys turn it into velocity data or acceleration data, you can ask the questions. Oh, did he get fired the week before? You guys follow me? If you get, do you think it's possible? Oh, if he got fired, it's more like, so what I'm saying is that he's happy, but he got fired, and then he suddenly just says that society and say, man, nobody care about me, I'll go commit a crime. So everything's here, okay? On page 145 to 146, you can copy, paste, get rid of your original data set. And what I'm saying is this, okay? No, I'll come back this later. No, I can do it right now. Erase it. Yeah, let's do it right now. Proc print, run. Okay, if you have your data set, okay, I'm going to just do a small set, and you guys can do the rest for the next homework, okay? I know I have 400 subjects, but I'm only using, say, 10 of them to show you this, okay? Once you have everything's done here, you can have rather this is employed. You can change this from employed to quit, and how to generate a quit set. Okay, let me just do this. Okay, and we're not changing anything there except this. We'll Control H, change employee to fire, or no, just off job. Okay. Okay. Now we'll just have this many say off jobs. And what you do is for each one of the off jobs, you just say that, I cannot see if they off job the first week. So just first week, put dot, 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 dot. Dot means I cannot measure that first week. And then from the second week on, you just say that, okay, if this second week minus the first week, okay, you know that the first week minus second week, here is 1. 1 means what? They got jobs. But if it's -1, okay, they don't have jobs. So rather than measure jobs, you can do this if they got quit. So everything's the same, except that now I'm not interested in their employment record. I'm more interested in how many times they are salary and desalary. You can plot and play the same games this way, using the same code, other than just changing a few lines. Follow me? And can I play the same game and just using 3 weeks of data, using the accelerations? You know, how many times on, off, and you change the data set, and then you just run the same things again, changing the name rather than employment. You're doing the other one, okay? Now, before I go any detail into this, I want to explain a little bit about tied data, okay? SAS use 3 different approaches to deal with tied data. And tied data is not possible to think about in live regression, because live regression is just that flat coming down, and there's no ratio to provide that kind of information. But in PHREG, you can do that. There are 4 different methods to do that. One is called exact method. One is called discrete method. The other one are 2 approximation. One is called EFROM. One is called Breslow method. Okay, and let me give you the comparison first. This is the old days. Okay, the computer speed is not very fast. Was the data set, okay, was tied data. This is how long it runs to get to the answer. This is on page 136. I just want you guys pay attention here. look, which one is ridiculous to figure out the Thai data? Exact, 204 seconds to deal with our data set. Okay? Discrete, 26 seconds to deal with the data set. And Breslow and Ephron increase or decrease in a linear fashion, 3 seconds, 4 seconds. So your data set, move from 100 to 1200, just increase a little bit. But if you use discrete exact method, is what? Is almost like 50 folds of time. When you deal with large data set, like shopping season, how many people bomb their credit card record by shopping how much? Do you think people are more likely to bomb their credit card if they shop a lot? Or they shop a lot of over $200 of gift? So if you want to estimate that kind of Thai data for any major business estates, on page 136, just put that down. Don't use exact method unless your boss says so. Don't even use discrete method unless your boss says so, because that roughly right answer usually give you pretty decent approximation. But if you use exact method, I don't know how quick is this computer. My computer is pretty quick too, but I'm just what I'd like to show you the example here is that okay. Okay, I'll just do the Thai data. Save as Thai data. Okay. And the approximation, I'll come back and explain to you what is that. SAS default is using Breslow. Okay. So you can hear just using discrete or Ephron. Okay. And if you compare, okay, the outcome here, it will show you. See, here is Ephron. Here is discrete, and here is exact, okay? And the answer we get usually 37902 for finance. 37902 for finance is based on, I think it's based on Ephron, okay? And the benefit of using exact only when you try to approximate, try to estimate the parameter very, very close to your, you try to correct your live regressions. Remember I just showed you live regression and the PHREG in Weibo is interchangeable. Unless you're doing something that advanced, okay? Usually, the take-home message here is page 136. Okay, don't pay the price for this, especially when you have who knows, billions of large data set, and your boss want an answer quick. Just remember, put ties equal to Ephron. Don't use discrete or exact method. And what's the difference between exact and the other one here is the, see, say I have 120 partial likelihood I need to estimate. So here are the inmate, right? But if suppose that I have 3 inmates got arrested in the same week, all I know is they got arrested in week 12. Do you know which one get arrested first? So could be, like here, could be A912, could be 12A9, could be, so in other words, there are, if I have 5 people got arrested at the same time, how many possibility about their sequence? Which one get arrested first? Which one get arrested second? It's 5 factorial of possible combination. So exact method will estimate all 5 factorial. That's 120 different possibility. So how many people you think gonna bomb their Visa card in the shopping week once the shopping start? A lot, right? So if you and every day, I'm pretty sure Bank of America, Wells Fargo, all the major banks here, they're doing that kind of approximation all the time. They need to come up with what they call red flag list. Here are those people. Watch them. The way how they behave, the likelihood they're going to bomb their credit card is going to be quick. And they need to do something about it. Or there are unusual, international transactions going on. Maybe someone's credit card got stolen. And how likely you think your credit card get hacked by somebody, during the shopping season? Very, very likely. Last year, guess how my credit card get hacked? And just suddenly realize that a bunch of those, you guys know what is Bionicle, kind of like a Lego game set. I just start spending like $10 buying over 100 sets of that. And so suddenly they just say, stop that credit card. Something is fishy there. And I call and say, why you stop my credit card? I cannot use it anymore. Actually, I was travel. And they just said, well, we have a strange transaction going on right now. And so think about this. When something like this happens, you want reaction time quick or you want exact answer? Reaction time is quick. So approximate that value here and says that, the outcome, exact number is 37902, not 37942. Does it really matter? All you care about is that the risk ratio just suddenly jump. If there is a risk ratio suddenly jump, you can say that when this number go beyond certain risk, stop it. Okay, and that's the reason. And the other way they can approximate it, the both way are pretty slow. The other one is called discrete method. The discrete method is using the log likelihood ratio. And basically, I think you guys, I asked you guys did a neural network or logistic regression when we talk about, what's that? Logistic regression in psychophysics. And this is basically the same things. Odds of saying yes versus odds of saying no. So you can approximate this by using the 2 odds and to get an approximation now. Okay? In the paper regarding the 2 comparison of method, the 2 very, very sweet and fast method approximation, One is called Breslau, one is called Ephron. All I can tell you is that it's really useful, but I'm not going to get into the math, how those two approximation methods develop. The only thing I want to say to you is this. One, do you understand how to use Thai data? All you need to just say is in your code. Okay? Thai. Where's my Thai? Yeah, Thai. If there's a Thai equal to Ephron, or there's a Thai equal to approximation. Basically, I heard this, I don't know if it's true. Someone got fired, and he doesn't like, what's going on. Guess what he did for all his SAS code, or R code? Before he left, he turned all his Thai equal to word change to exact. And what happened? Whoever took over his jobs, suddenly everything slowed down. You cannot react quickly. This is all related to reaction time. Okay. Next. Okay. Now we're going to move to a really interesting topics. It's called PHREG for competing risk. And what is competing risk? That is the material of chapter 6. Okay? And chapter 6, competing risk. The magic words for competing risk is there are more than one way you can get killed. Okay? Heart attacks, all kinds of problems. So the data set he come up with in this book is also the reason I like this book so much, is he talk about the following. Okay? Show you the data first. He compare, okay? He copied this study, compare in the 100 years of all over the world, of all the world leader, and said the leader could, out of power, out of their positions, from a position for 3 different reasons. Death, due to natural cause, die-o. The leader, the president, die-o. The queen, die-o. Right? We just have a queen die, o. The other one is constitutional means they got voted out. And then there have a non-constitutional means that they got assassinated. So every world leader in the last 100 years, especially before and after Second World War, there are a lot of new nations developed, and some of them die quick, get out of power quick. So how long the leader at power or got kicked out is their survival time. And so their survival time, they turn this into a regressions. First, let's just look at a variable, see if that makes sense to you. Number of years in power. Do you think that makes sense? If someone got in power longer, you think it's better or worse to get kicked out? Huh? Well, in the United States, it's one thing. Well, they talk about this recently. They said that our Congress is getting really old. We have a lot of old congressmen. Okay, I think this is depending. You talk about North Korea. People hold the power until they die, right? But what happened in China? You guys know what happened in China? Xi Jinping's got a 3rd term. And how did they do it? It's not through democratic process, but they just say, we extend the, originally you can be president only 2 terms. Now they said, oh, you can have 3 terms, right? They just changed their constitution. Okay. Next, 012 is 0 means they still have power. 1987. I was in grad school when I read this. 1, constitution, natural cause, non-constitution. Manner, how did a leader reach power? Constitutional means or non-constitutional means? Military coup. If you get a power from military coup, how likely you could get killed because of military coup? All right? So, violence begets violence, right? Year of entry into power. How long is star? Background. Military leader versus civilian leader. How likely you think's gonna show they how many president of the United States with military background? Really? Name a few. Huh? Okay, who else? Okay. What about Eisenhower? Eisenhower was 5-star general. He is the command of the Allies in Europe during the Second World War, right? Actually, Eisenhower was MacArthur's chief of, but obviously Eisenhower got more diplomatic skill set and all the other stuff, right? MacArthur got fired by Truman, okay? Who else got military background? Who served in the military? How many? Oh, of course. And who else? Carter served in the Navy. Kennedy, JFK served in the Navy, okay? But they're not become leaders fully. I think they're not become leaders because of their military background, right? They campaign. Carter was the governor of Georgia, right? And next. Okay, but you think that they're more likely to get killed in one way and not the other way. Age. Do you think age matter? At least age matter if they die old in their office, right? But how old is old enough? Next, conflicts. Ethnic conflict. 1 is medium or high. 0 is low. Okay, and where are the conflicting most troublesome region right now in the world? Anybody knows? You don't follow news? Ukraine? In Europe? Africa, of course, but usually we don't pay attention to Africa because, their impact on the world economics is not as high. What about in Asia? Where is the hotspot? Taiwan. Okay. So GDP. Do you think high GDP, low GDP define how the leader gonna get kicked out? Rich country or poor country are more likely to have a military coup? Poor country, right? And you tend to have a lot of people not so happy. And actually, you guys can go Google, okay? The CEO of the Japanese, I think the Sony, Panasonics, and he said one thing. He said that when your country is very, very poor, you can sell any ism, communism, whatever ism to the people. And they tend to believe that. But when your GDP over $300, you can sell them anything. But if it's over $3,000, they can start buying motorcycle. They will talk about it, but they don't really exercise it. But if it's over $10,000, they don't care what ism you're selling them. So, GMP define. You guys know what's GMP, right? Okay, and GMP is not GDP. Okay, but GDP is not GDP per capita. Which one is the better estimation of your personal income? GDP per capita. Okay, growth, annual growth rate. Do you think that you have a high growth rate, your country is safer? Or the leader's positions is safer? If you're in a boom time. If everybody get jobs, economics is growing, they are less likely to say, hey, we want to have another midterm elections, or we want to do some military or something to kick the leaders out. Okay, population. Large population versus small populations to have problems. Okay, where are the large populations? Name a few largest populations in the world, countries. What else? United States is not that big. It's big, but the United States is, the United States is on the top, but Indonesia, okay? There are countries, and sometimes you will say that, how come I never heard that? Because they usually not on our radar screen, okay? And land area, by the way, do you guys think this kind of study will be useful if your company want to invest internationally? Well, if you, I give you another example, you work for DOD, and your divisions want to export certain weapon, some drones, some AGV, AUV, whatever V to a different country. Do you think you care about the political stability of that country before you say, oh, we want to export this? Yeah, so there are good reason to study stuff like this. Next, land, big land, small land, literacy, and Middle East, Africa, Asia, Latin America, and look at here, okay? Number 4 is North America, Europe, and Australia. Why did I put it that way? Oh, this is before the Berlin Wall. The study was done. At least those regions are pretty stable. Usually nothing happened, okay? All the troublesome spots are on the top, okay? So here is the storyline. So next will be how to do this, okay? And let me just use the code I'll run a SAS next time, okay? When you run this program, okay, first show here, okay? Proc live test. So we're just plotting them just for fun, okay? Data world leader, and then we can do the survival output for different set. But I want you to pay attention to is time, year, loss. Look at the number inside your parentheses, okay? Sensor 023, sensor 013, sensor 012. What does that mean? I have a whole data set. If I'm only care about those people got voted out, I can't remember 1, 2, 3, which one. Okay, I think one is natural cause of death. So if I want to study 1, 0, 2, 3 will be censored out. If I want to study 2, got voted out constitutionally, I will censor out 0, 1, 3. Finally, if I want to study people got voted out in a non-constitutional way, I will censor 0, 1, 2. So this kind of operations, usually you can censor as many things as possible. So you can have a multiple choice. Same set of data, okay? You can go to the morgue or a major hospital and say that, okay, I want to see the death record of the last 20 years. And you can use that to see that what are the major causes of death in that hospital by doing this. Can you see that? And if you have major risk in one area or in the other area, when you lump them together, you say, oh, this hospital is okay. You know, the death rate or the casualty is not high. But once you divide and conquer, censor, focus on one at a time, you will say that, well, how come all your heart disease or your respiratory disease tend to have higher fatality rate? And then you can say, oh, maybe, you speculate. Is the filter of the air or the environment is questionable? Then you get into the next step is you have to run the whole things and say that, oh, let me have different covariate, right? All the variable will be involved, and with the Thai data and everything. This is the stuff on page 195, and we can have strata based on region. The region by. Do you think doing this region by region makes sense? The world leader. Yeah, based on the news we learn, it makes sense, right? But here's the things usually people try to figure out is the following, okay? I'm coming back later on, okay? Here is the group, okay? One is just, die due to natural cause. You got a bathtub shape of the hazard function, die, slow down, die young, slow down, even out after a certain time, and then increase, and with different rate. And what I'm trying to say here is that you can decide your strata or your censorship based on different assumptions here. For example, in hospital, do you think that combine the COVID fatality with all the respiratory disease together makes sense or doesn't make sense? Huh? Makes sense? But if you do that, you could bury all the data in there and say, oh, the rate is not high. But if you single them out, you suddenly realize that the rate of fatality is high. So the game here is, at the end, we can say that, oh, when I do the censorship, maybe I'll censor, what I'm saying is that if I have 1, 2, 3, 4, 5, I can combine 2, 3 together, only censor 1, 4, 5, and say 2, 3 are the same group. You follow me? So when you do this, you can combine different group of disease or problems together. Now, before I let you go, if you can answer these questions, okay, if she can answer these questions. Oh God, you try. Here, let's see if you pay attention. Generally speaking, okay, would you like to have the world leader classified them, their, say their risk, the competing risk, into if I can classify them in 10 groups of 10 different kind of risk versus 5 different type of risk, okay? Generally speaking, would you like to, the devil is in detail, so we would like to classify them into as many groups as possible, correct or not correct? Correct? Okay, from a system engineering standpoint, okay, do you like to have 10 model or you like to have 5 model? Okay, so when you do homework, would you like to have 5 survival curve, or you like to have only 2 or 3 survival curve to compare?
I would like to.
Yeah.
If I want to be more thorough.
But so generally speaking, competing risk, we don't want to have all kinds of competing risk because that will make our life miserable. So in other words, we always try to start simple. Unless there's a good reason for us to go complex, we'll stick on the simple one. And I'm not joking, okay? There is a way to explain this. It's called Chinese restaurant problem or Dirichlet process. Restaurant problem. Okay, Chinese restaurant process. Okay, and I want you guys can read it yourself. It's really about probability and modeling. What it really said is that in San Francisco or in Chinatown, there are Chinese restaurants, and they have, say, 5 or 4 tables. And if you eat, you can pick any table to eat with, join the table. And unless your food, your selections is so different from others, your preference is so different from others, then you can start a new table. And from a restaurant's operation standpoint, you want to have few table or you want to have a lot of table, as few as possible. So the process here or modeling effort here is always the same things. Start simple. Unless I need to come up with something else, I'll divide them into different groups. Okay? So next week, I'm going to go through competing risk and explain how to model it and give you another, maybe a little bigger homework to play with. And after that, reasonable torture is required. Otherwise, you're not going to remember how to use some of the procedure. And you may not use SAS, but sooner or later, all the techniques we're talking about, I think you cannot get away with it in your career. Okay. Then after that, I'll talk about some of the so-called redundancy. And basically, now we have the modeling, how to build model in a parallel or sequential way using schematics. And at the end, I will cover a little bit of copula. Those 2 topics are a lot more advanced if you want to do it right. So I'm probably not going to have, depends, okay? If I think it's fun for you to do a tiny homework, I'll do a little bit at the end, and that'll be the end of the semester, okay? Okay, adios, see you.